As we've seen, for loops are useful when you have a known number of items to iterate through, from 0 to 4 say. But sometimes you may not know in advance how many items you need to process. For example, you might write some code to format the lines in a text file, but each file may contain a different number of lines, so you can't assume in advance that there'll be a specific number of lines to process because when you write the code, you don't know which file you are going to be dealing with. Or maybe you need to prompt the user to enter a response, such as Y or N for yes or no. And maybe you want a certain piece of code to keep on running if the user enters Y, but to end if the user enters N, or vice versa. Well, here's a while loop that does this sort of thing. In this case, the code inside the block, delimited by the curly brackets, continues to run while the char variable C is not Y. The user is prompted to enter a character, which is read from input and assigned to the char variable C. When Y is entered, the test, while C is not equal to Y, fails, so the code stops running. If any other character is entered, the test succeeds, and the code runs all over again. Now, you might wonder why I have a second call to get char here. That's because when the user enters Y or N, the line feed character itself is also entered when the return key is pressed. My second call to get char simply mops up this unwanted line feed character. If you need a more robust way of reading characters from the keyboard, refer back to the readlin function from step 4. Now, we also used while loops in step 4 when we had the problem of flushing the user input. You might remember that. I had to carry on reading any characters that the user had entered while more characters remained to be read. Well, in this present program, I'm dealing with a much simpler case, so I'm just not bothering to do that. I'm just mopping up the character with this second call to get char. So let's run this. Okay, so here's the code running. Let me try entering N, it prompts me again, N prompts me again, Y, and it falls through to the end. That's all, folks. So as I intended, if the user enters anything except Y, the loop continues running. Only when Y is entered does the test here evaluate to false, because it's only true when the character is not Y. And in this case, for simplicity, it has to be a lowercase y as well. I haven't dealt with uppercase y's. But look, in my code here, C is initialized to a space character, and it'll never be Y unless the user enters a Y character. Well, that's okay. But let's assume that I decide that I want the default value of C to be a lowercase y. So I make that change. And now, what's the difference here? Well, in fact, what happens is that when this runs, and let me see this again, so this time it goes right through the loop. The loop never executes. The code in the loop is never run. But that's because the test up here, C is not equal to Y, fails immediately because C is Y, because I've initialized it to Y right at the outset. As a result, none of my code inside the block can ever be executed, no matter what happens. So how can I be sure that the code inside my while block here always runs at least once? And that's what I really want to happen. Well, I'll explain how you can do that in the next lesson.